Pre-statistics. Parameter, value, mixture, and break-even problems involving systems. Part 2. Lesson objective. Use a system of two linear equations or a linear function to solve parameter, value, mixture problems, and break-even problems. Example 3. The American analog set will play at an auditorium that has 400 balcony seats and 1,600 main level seats. If the tickets for the balcony seats cost $15 less than the tickets for the main level seats, what should the price be for each type of ticket so that the total revenue from a sellout performance will be $70,000? So our first step is to define the variable. We're going to let B be equal to the price of the balcony seats and M be equal to the price of the main level seats. And these are both measured in dollars. Next, step 2, we want a system of two equations. So the first equation will be expressed from knowing that the balcony seats cost $15 less than the tickets for the main level seats. So we would say B, the balcony ticket price, means equal sign, and 15 less than main level ticket price would be M minus 15. So we have our first equation. We want the total revenue to be $70,000. So the second equation would be where we apply the total value formula. So we have B times 400, where 400 is the number of tickets, B is the price of the ticket. Then we're going to add the number of main level tickets, which is 1,600, times the cost of each ticket, which is M. And we want this to be equal to our total revenue, $70,000. The units on both sides of the equation are in dollars because we have dollars over balcony tickets times balcony tickets, which these will cancel. So we have dollars plus, same thing here, the main level tickets cancels out with this main level tickets, and we have dollars, so dollars plus dollars equals the units here, which is dollars. So this suggests that our work is correct. So the system is B equals M minus 15. That's equation 1. And equation 2 is 400B plus 1,600M equals 70,000. Given this system, I think the easiest way to solve would be by substitution. Using equation 1, we know that B is equal to the expression M minus 15. So I would take the second equation, and everywhere I see a B, I would substitute the expression M minus 15. So we have the second equation, and after the substitution we have 400 times M minus 15 plus 1,600M equals 70,000. So this equation has only one variable, M, so we can solve it. So first we do the distributive property. 400 times M is 400M minus 400 times 15, which is 6,000. The next step is to combine like terms. So 400M plus 1,600M is 2,000M. Next, we add 6,000 to both sides, and then we divide by 2,000, and we see that M is equal to 38. So if we go to equation 1 and substitute 38 for M, we can find B. So we have B equals 38 minus 15, which is 23. So the balcony seats are priced at $23, and the main level seats are priced at $38. Last step, we check. So the difference in the price will be M minus B, and that should be equal to 15, and it is. And the total revenue will be the cost, 23, times the number of tickets for the balcony, which is 400, plus the cost, which we found M to be $38, times the number of main level seats, which is 1,600. These two add up to be 70,000, so it checks. Example 4. A 10,000 seat amphitheater will sell general seat tickets at $45 and reserve seat tickets for $65 for a Foo Fighters concert. let X and Y be the number of tickets that we will sell for $45 and $65, respectively. Assume that the show will sell out. Number 1, find T, which is equal to f of x, be the total revenue in dollars from selling the $45 and the $65 tickets. Find the equation of f. Solution: add the revenues from the general and the reserve tickets to find the total revenue T. So T will be equal to, and again we're going to apply the total value formula, the cost of the general ticket times the number of general tickets, which is X, plus the cost of the reserve tickets times the number of reserve tickets, which is Y. So we have T equals 45X plus 65Y. So now we have T in terms of both X and Y. So we have two variables and only one equation. Now if we can put T in terms of X, then we will have one equation with only one variable, X. So the total number of tickets sold for a sellout is 10,000. So this implies that X plus Y equals 10,000. Solving for Y, we have Y equals 10,000 minus X. If we substitute 10,000 minus X for Y into our first equation, we will have one equation with nothing but X's. So we have T equals 45X plus 65 times the quantity Y, which is the same thing as 10,000 minus X. Next we use the distributive property, combine like terms. We have a negative 20x plus 650,000. So we have our equation. F of x equals negative 20x plus 650,000. Number 2. Use a graphing calculator to sketch the graph of f for the domain from 0 to 10,000. What is the slope? What does it mean in this situation? Solution: to sketch f, we first want to enter the equation in y1. Then we need to set the window settings. We want the domain to be between 0 and 10,000. I'm going to count by 1,000. For the y min and the y max, I'm going to set it at negative 100,000 for the min, and for the max will be 700,000. And I'm going to count by 100,000. Hit graph. This is what my graph looks like. So as we see from the graph here, this is a negative slope. And from the equation we know that the slope is a negative 20. And what does that mean in the terms of this problem? That means as the general tickets increase by 1, the revenue will decrease by $20. Number 3, find f of 8,500. What does it mean in this situation? So f of 8,500 means when x is 8,500, what is y? So substituting 8,500 in for x, we have negative 20 times 8,500 plus 650,000, and we have 480,000. So in the terms of this problem, it means that if 8,500 tickets sell for $45, which means 1,500 tickets sell for $65, the total revenue will be $480,000. Number 4, find f of 11,000. What does it mean in this situation? Solution: again, substituting 11,000 in for x, we have $430,000. And that means if we sell 11,000 tickets for $45, the total revenue will be $430,000. Now since there's only 10,000 seats available, we have a model breakdown as we are going outside our domain. Therefore our answer doesn't make any sense in the terms of the problem. Number 5. The total cost of the production is $350,000. How many of each type of ticket must be sold to make a profit of $150,000? Solution: a profit of $150,000 would be that's what we make beyond the total cost of the production. So if we take the cost of production, which is $350,000, plus the profit that we want, which is $150,000, which means the total revenue will need to be $500,000. So next we substitute $500,000 for T, and then we solve for X. So we have 500,000 equals negative 20x plus 650,000. Subtract 650,000 to both sides. We have negative 150,000 equals negative 20. Divide by negative 20. Negative divided by negative is positive, and we have x is equal to 7,500. So 7,500 $45 tickets and 2,500 $65 tickets will need to be sold to have a profit of $150,000. Thanks for watching.